I need to start by reminding us that radiation impacts our cells. The reason I bring this slide forward is that we can't see radiation, but we can see the impact it has because it chews up chromosomes and you get abnormal ones, and the dicentrics actually are becoming a biomarker. And if we get a whole lot more work on this done, like if someone gets into big data on people who've had cancer treatments that include a lot of radiation, we could actually figure out how to have evidence that could hold up in court that someone has been irradiated. Okay. The radiation has lots of many different outcomes. We now know this. Cancer is not the only outcome, but our government acts like cancer is the only outcome from radiation exposure. It's the only one that's tracked. It's the only one they've put lots of money into studying. And so it is the key marker in terms of health effects. And this slide just reminds us how it happens. On the left-hand side is the energy hitting a cell. That is where damage occurs, our cells. Inside the cell is the DNA. This is one type of damage. It's not the only damage. We have incredible cellular repair mechanisms that can repair some damage, but unfortunately not all. Sometimes the cell dies. If that happens, no big deal. Our body absorbs dead cells all the time. But the problem comes is if a cell has been damaged, not repaired, or not fully repaired, and it sits there. And the more abnormal cells that sit around in our bodies, the greater the chance that some second event is going to trigger them to start growth into a tumor. Now, nobody can prove which abnormal cell came from radiation exposure or which of them will end up as resulting in cancer or some other health outcome. But in general, the more exposure means more abnormal cells equals higher probability that it's going to come out bad. However, the other side of radiation is something called the stochastic effects, which is why we say there is no safe dose. A single radioactive emission damaging a single living cell creates the potential for cancer. An undetectable level of exposure is, and its outcome is what's called stochastic damage. And the probability of it goes up with more exposure, but the level of results really doesn't change. So it's not the same as the other deterministic types.